Suppose we have a pool ball that's going to leave a 0.60 meter high table with initial horizontal velocity of 2.4 meters per second. Let's say we want to predict the time to hit ground. The only information I would need to use for this one is the vertical height, because the horizontal distance really has no effect on the time to hit the ground. So this is a distance, and I have a time, and because it's vertical, I'm also going to have to include g in here, because g is the acceleration due to gravity. So if I have distance, g, and time, I'm going to want to use d equals 1/2 gt squared. So I plug in what I know. I got 0.60 equals 1/2 times 10 times t squared. So that's 0.60 equals 5t squared. Then we divide both sides by 5, and we get t squared equals 0.12. And then to get rid of the square, I need to square root it. So that gives me, let me see, get my calculator out. That would give me a time of 0.35 seconds. Now in the next part, we want to predict the horizontal distance between the table edge and where it lands on the ground. So it's going to kind of follow this. So that is also a distance, but this time it's in the x direction. So because we're looking at a distance in the x, we also need to deal with the velocity in the x, and we do have the time that the ball is in the air, so this is going to be my time. To find horizontal distance, I want to use the velocity triangle, which is v equals dt. I can only use this triangle in the horizontal distance because there's no acceleration. I cover up the d, so dx equals vx times tx. Now this time that it's in the air is also the time it takes it to go horizontally. So that's what allows me to use that. So then I go 2.4 times 0.35, which gives me, let me see, which gives me a distance of 0.83 meters.